Okay, support is seminar 2026. As we have expected, this question is based on principle of moment, isn't it? Right. Draw the experimental setup used to determine the mass of an object using the meter ruler in the physics lab in the space given. That means using principle of moment, we can determine the unknown mass, right? For that, these are the instruments needed: meter ruler, knife edge, and a wooden block, right? Initially, we need to balance the meter rod uh, on the knife edge, right? If it is horizontal, we can say the center of gravity of the meter rod is at the knife edge, right? Why we are doing so? Because in calculation, when you do any calculation, right, the weight of the meter rod won't appear, right? Because one end of the meter rod we have to hang the unknown mass, example M. Other end we have to hang the known weight, right? Known weight mg. These two masses, right? For example, if the unknown mass is nearly 50 gram, right? Before finding the exact value, right? We have to know the approximate value, right? Say for example 50 gram. This weight also, right? We have to take as 50 gram. Then only when taking the measurements, that means L1 and L2, we can we can measure the length in a wider range, right? That we are aware about that. Meantime, we need to keep this wooden block in the, we have to keep this wooden block on the table because then only we can maintain a reasonable height. Otherwise, right, or if we only use the knife edge and hang these masses using the string on the meter ruler, right, sometime this weight will touch on the table. To prevent that, we can have a wooden block. So the possible experimental setup is like this, right? Possible experimental setup is like this. So in this blank, we have to draw the uh, experimental setup, right? Let's say the same, right? Your meter ruler, right? The knife edge. Need to keep the ruler on the knife edge, and the knife edge should be placed on the wooden block, right? This is the meter ruler, and unknown mass we have to hang on one end. Determine the experimental setup used to determine the mass m of an object. We can hang it on left side or right side. It's not a matter. It's not a matter, but according to this, the diagram is given now. According to this, small m is on the right side, right? Diagram is given, so from this we can pick the idea, right? Idea is there on the paper, right? So according to the paper, that small m is in the right side, right? It is not a matter, right? We can hang it on left side or right side. It's not a matter, right? Mg and this is unknown Mg. And known weight, we can hang it on the other side. Right. This is M naught. Okay. And from the pivot, the help is there, right? Just look and draw. Right. This is Y and this is G. So we can mark these lengths as X and Y. Right. More importantly, we have to indicate everything. This is wooden block. Okay. This is knife edge. Right. This is unknown mass. And this one is known mass. This mass is nearly equal to this, and only x comma y we can measure in wider edge, right? This is meter ruler. So this is the possible experimental setup. Draw the experimental setup. Okay, that's okay. What amount of mass m naught do you choose here for? The known mass. Here for the known mass. Known mass, it should be equal to the, right? Nearly that this m naught equal to this, or the value of m naught close to m. So we can say it's your own, right? No need to write the exact answer on the scheme, right? But this m node nearly should be comparable with this. Then only x and y can be measured in wider range. Okay. So value of m node close to the value of m. Okay. Explain the reason for the selection. Right. Why? If m node nearly equals to m, the values of x comma y will be slightly equal. Right, x comma y will be measured in wider range. Can be measured in wider range. Can be measured in wider range. Right, but if we keep this is very much bigger than this, what will happen when we take moment? For example, the unknown mass is 50 gram, right? This is 100 gram. Then at the equilibrium of the meter rod, this length will be smaller than, right? Because moment is mass weight into perpendicular distance. So what will happen? This length will be, right, y will be smaller than x. If y is very much smaller, then there are many errors will occur, right? Percentage error in measuring y will also increase, right? X will be in wider range. Y will be small. So this is not good. If we keep these two masses nearly equal, that means nearly comparable, then x comma y will be comparable. That means x comma y can be measured in wider range, right? That is the theory. What are the values of x that you select if you are supposed to get 5 sets of readings? What is that? What are the values of x? Uh, right. The center of gravity of the meter ruler provided for the experiment was 51 centimeter mark. Right. Further, to select the unknown mass M nodes, set of slotted mass. Slotted mass in the sense there will be a hook and a weight. For example, this will be 250 gram, and some disc-like weighted masses will be there. Right, we can attach this so that gradually we can increase the masses. Right, when there's a necessary to increase or decrease, we can hang a fixed value also. Right, that is slotted weight. So the center of gravity of the meter rod is 51 mark. Further, to select the unknown mass M node, set of slotted masses 110 gram were given. Total mass is 110 gram. A student performed the following experiment to determine the suitable known mass. He balanced a meter ruler at the center of gravity, and the unknown mass M is hung 40 centimeters, say x, from the center of gravity. Then, with 70 gram mass, the balance length was 43 centimeter, while the balance length became 39 centimeter when the mass was 80 gram. Right? Okay. The thing is, we need to understand what they are saying, right? Just have a look on this. So this is a meter ruler. Meter ruler is balanced on 51 centimeter mark, right? One end, the unknown mass is hanged. Other end, they are choosing to balance. They are choosing different masses. When 70 gram mass is chosen, right? The balance length was 70 gram mass choose. Balance length was 43. While the balance length, when choosing 70 gram, yes, he balanced the ruler at the center of gravity. The unknown mass M was hanging at 40 centimeter. Right, this is the unknown mass. This is the unknown mass, unknown mass. This is known mass. Unknown mass is hanged at 40 centimeter. Right, say x from the center of gravity. Then the 70 gram weight balance. So balance length is 43 here, right? As we have already explained, right? X and Y should be comparable. Y is slightly greater than X in this case when we choose 70 gram. Instead of choosing 70 gram, if we choose 80 gram, the balance length was 39 centimeter. So there are two options. One is 43, other one is 39, right? This no, unknown mass is hang from the center of gravity 40 centimeter. Now compare these two, right? 40 centimeter and 40, 39 and 40. Which one is close to this 40? This is the closest one. So best value for known mass is 80. So that is the question. Which mass do you use for the unknown mass or not? So we can say mass 80 gram mass. 80 gram mass. I think okay. Third one. Next one. In this experiment, which side do you select to hang the unknown mass M? Whether it is in 0 to 51 centimeter arm or 51 to 100 centimeter. The diagram is given, right? Because look at this. The unknown mass is actually hanged on according to the previous one. 39, right? What is the question in this experiment? Which side do you select to hang the unknown mass model? Whether it is in 0 to 51 range or 51 to 100 centimeter range. Look at that according to what is given here. For 80 gram known mass, the balance length was 46. According to unknown mass M was hanged at 40 centimeter. Unknown mass M is hanged at 40 centimeter. 40 centimeter is actually within the range 0 to 51, isn't it? So we have to keep that within 0 to 51. Right, so 0 to 51 centimeter arm is the option. Okay, see, what are the values of x that you would select if you are supposed to get 5 sets of reading? 5 sets of reading in the sense, the range is actually the for x value right, x is in this range 51 to 100 centimeter range x. So we can go up to, gradually we can increase, no? What are the values of x that you would select if you are supposed to get 5 sets of reading? X value 10 10 10 we can say, no? 10 centimeter we can measure first, then 20, then 30, right? Because it's nearly 49 divisions are there, no? So 10, 20, 30, 40 and 50. So 5 sets of reading we have to get. Okay, 10 centimeter the first value, 20 centimeters the second value, 30 centimeter, 40, then 50, right? Then we can get 5 set of reading. 10 centimeter in the sense from the pivot, this is the pivot, from the pivot to the hanging point, right? This is mg, right? Initially we can we can set as 10, then we can increase to 20, 30, like that, up to 50 we can increase, right? The third one, The figure given here shows the setup used to determine the unknown mass. Actually, right, this is a wrong setup. Right, earlier, right, they have asked to draw the diagram. Diagram is given here, no? Then meaningless, right? The figure given here shows the setup used to determine the unknown mass as well as the mass of the meter, right, meter ruler, right? This is something different again, right? Here G is the center of gravity of the meter ruler and D, where is D? D is a constant value. This is the center of gravity. This is the pivot, right? At the equilibrium, right? Left side there's a mass m naught g, right side a mass mg is there, right? Meter rod, mass of the meter rod is m. This is at the center of gravity. This is the pivot, right? What they are asking. Write down an expression for the balance situation using the symbols given below. Expression in the sense, if we take moment, say let's say this point as O. If we take moment about the point O, left side moment equal to right side moment. That means m naught g into y equal to capital Mg into d plus small mg into x. That means gg is cut. So we can say m naught into y equal to, write the expression for the balance situation using the symbols given above. So we can keep like this, or we can say m naught y is equal to, use the symbol given above in the sense you can leave it as it is. This is okay. Rearrange the above relation for the determination of the mass m for the object and the mass of the meter order, right? In this case, we need to find the unknown mass m as well as the mass of the meter ruler, right? So that we have to rearrange this. How we can rearrange? M naught into y is equal to m into d, capital M into d plus small m into x. So we can rearrange this. This is like y is equal to capital M over m naught times d plus small m over m naught times x. So y is equal to small m over m naught times x plus capital. Okay, so we can rearrange like y is equal to m over m naught times x plus capital M over m naught times d. They have stated d is constant. So d is constant, capital M is the mass of the meter rod, that is constant. M naught is known mass, that also constant, because throughout the experiment we are keeping m naught and m unchanged. This is unknown mass, that also constant. So this is in the form of y is equal to mx plus c. Right. Make a rough sketch of the graph. Since the format of the graph is y is equal to mx plus c, right? Gradient is a positive gradient, so the pattern should be like this. Right? Should make this graph should make a acute angle to the x-axis. Right? How do you determine the unknown mass m? We need to find the gradient d. We need to find the gradient. So the gradient g, right? Need to draw a right angle triangle. From that we can find the tan value, difference of y or difference of x. Gradient is equal to tan theta, that is small m over m naught, because we know the formula y is equal to small m over m naught times x plus capital M over m naught times d. Okay, so this is y is equal to gradient, we can say g. So the gradient is m naught over m, right? How you can determine the unknown mass? So we have to subject the we have to make small m as subject. So MC equal to G into M naught, right? Okay, then how do you determine the mass capital M of the ruler using the graph? Then we have to find the intercept, right? Intercept, this is intercept C. C is equal to capital M over M naught, right? Gradient G is equal to small m over M naught. So if we divide C by G, it will be capital M over small m. Small m is actually the known mass. Sorry, unknown mass. Unknown mass is already right known. So we can find the capital M. How we can find capital M? Intercept over gradient into small m. Right. This is there should be a D here, right? C is equal to capital M or M naught into D. C or D in the sense there should be a D here. If we divide C by G, capital M naught will be cancelled out, right? M naught will be cancelled out. Capital M naught will be cancelled out. Then capital M over small m times D. From this we have to find the mass of the meter rod. That means capital M is equal to COG times M over D, right? Over D. Right, in the scheme this is wrong, right? They have mentioned small m as M naught. It should be M, right? Right. Right. What length do you choose for D? D is a fixed length. That means this is the pivot. From the pivot to the center of gravity of the meter rod, this distance they kept as a constant D. Right. As we know, right, when we measure the length in using meter rod, we have to keep the percentage error at least 1% or below 1%. Percentage error is actually the least count. Least count of the meter rod is 1.1 centimeter over the distance D into 100. It should be at least 1%. So from this, if we calculate D, right, it will be 10 centimeter. Minimum value, if we take a minimum 10 centimeter, then only we can keep the percentage error as 1, right? So at least we have to keep the D value 10, right? So according to what they have given, right, 10 is the best choice because of this formula, right? You can see. You are provided with the twin thread thickness of 2 millimeter and a thin thread of thickness of 0.5 millimeter with sufficient length. What string do you select to hang the masses? Right. The thing is, if the thickness of the thread is high, then when we hang it, right, it is difficult to find the right position of this because length we have to measure. If it is a thicker one, then it is difficult. 0.5 millimeter is the best choice because right, if it is a thin string, then we can easily find out the hanging point, right? So the thin string is the correct option. Okay. What is the error of measurements if you use the twin thread? Twin thread in the sense the thickness is high. What is the error of measurement? What is the error of measurement if you use a thin thread? Right, if we use 2 millimeter, right? Then in meter rod we can measure up to 1 millimeter, minimum up to 1 millimeter. Least count of meter rod is 1 millimeter. If we use 2 millimeter thickness of twin thread, then error will be possible chance of error. That means whatever reading you are taking, plus or minus this 2 millimeter, right? So error is 2 millimeter. But if you use the thin string, the thickness is 0.5 millimeter. But using meter rod, we can measure 1 millimeter. So the possible error is you are reading plus or minus this 1 millimeter, not 0.5, right? So this is the correct option for this.